we're going to do a quick rundown on the Nordberg console setup. So this has been rebuilt and we've actually pre-tested it. Everything's already been preset, but this video is to show and remind ourselves the order and what to set everything at. All right, so the first thing I want to talk about are the two pressure switches. We have pressure switch 1 and 2 in here, 1 in the back, 2 in the front. They're both labeled and the cords are labeled, and it says the set point of each one, and that's on rising. So that means when the pressure is set on these, pressure, it goes from low pressure, basically 0 psi, up to its set point, target set point. We've had our best luck setting these using an independent hand pump as opposed to the machine itself. Using the machine itself, we got a pressure gauge and it's a little less accurate. After those are set and we know what those are set at, the accumulator comes from the cylinder shop, preset to our specified pressure of 1200 psi. And then now we're ready to set our pressures. The order I found best to set the pressures at is we have an unloading valve. So you want to have a schematic with the numbers clearly identified for the settings. The unloading valve is the first one, so that this symbol down here is the unloading valve, and the value for that is 2000 psi. So what an unloading valve does is this is a two-stage pump, so we got two volumes coming out of it. When it's in its low pressure state, it's combining the two flows into one flow for the maximum amount of flow to extend cylinders. And then once the pressure builds up to a certain value, in this case 2000 psi, it unloads. So it unloads the higher volume output, which is considered our lower pressure, and then there's one smaller higher pressure that takes us up to our final set point. So that setting of that unloading valve is very important to have set right, and in this case it's 2000 psi. So first thing we need to do is figure out on the schematic how to deadhead something, and all of our hoses that go out to the machine in the real world are all plugged. So we figure out what to deadhead to get that pressure to build up, and then you can physically hear that unloading valve shift, and you can hear the pump and the electric motor unload when that higher volume gets unloaded. So our set point on that is 2000. Then after that, we want to take a look at our schematic and pick out the highest pressure. At least that's how I made logic of it. So our highest pressure is our relief valve in this Dynex valve at 2800 psi. So in order to access the adjustment on this Dynex valve, we have to actually remove this actuator assembly and then remove this protective nut to expose the adjustment. Okay, so once we have that set up, our next highest pressure is this branch relief valve for the lock post at 2600 psi. So what we'll do, we have the valve handle restored, and what we're going to do is figure out what to deadhead. So looking at the hydraulic schematic, this valve, this section of this valve has first priority. We're leaving this one in neutral because all ports are blocked. It's set up as closed center. So this valve right here, this first one on this right handle, has the first priority of this hydraulic system. So we're going to put it in this position right here, which is clamp, lock post clamp. And then we're going to run the power unit, and it's going to display the value of whatever this branch relief is set at. So we want to start out with a random, it's a factory setting, we don't know what that is at this point, so we're going to back that off just a little bit, and we're going to start the power unit, have this valve pulled in this position, and then we're going to read our pressure and come up with whatever that's set at, and then we're going to raise it up to 2600 psi and then lock it. Okay, then that is set. The next one after that we want to move on to is the tramp release relief valve, and that's 2400 psi, and that's in this small integrated block right here. In this block we also have a needle valve, which is there for unloading the tramp release cylinders. So that plastic knob has to be tightened up in normal operation. It only gets open for decommissioning or maintenance or some other special event. So the relief valve is right behind it, the tall stem. So in order to set that relief valve, we need to look at the schematic and figure out, okay, what do we do to deadhead that line to expose what that relief valve is set at. So on this circuit right here, we pull this handle right here. We pull and hold it, and that'll expose what that pressure is set at. Of course, we have to have a gauge on that line, on all these lines, to know what pressures we're at and trying to get to. So in order to do that, we pull on this valve, and then we're able to make that setting on it. All right, so what we have here are all of the customers' working lines that go out to their machine. In this case, we got them labeled very, very well. But what we're showing here is that each working line is positively plugged off. Right here we have an unloading valve, with this being the adjustment. It's an aluminum knob, a 1/2 inch lock nut. So right now it is set at its target of 2000 psi, and the lock nut is snug. The lock post branch relief is right here. That's the one that we're setting to 2600 psi, and the adjustment is on the end. This particular one has a plug that hides the adjustment, so the plug comes off, and then you can see the adjustment. You make the adjustment, install the plug back on. When the plug comes off, it'll leak a little bit of hydraulic fluid. That's okay, it's normal. And then the plug will obviously plug that back off. This is the small integrated valve with the tramp release relief valve. This is the knob for the needle valve that needs to be closed, so clockwise, snug. And then this is the relief valve that gets adjusted to 2400 psi, so this one just has a standard lock nut and a Allen key to adjust it, and that's the 2400 psi. Right here we have a flow control valve. In this case it's a manual inline style flow control. Some of these will have a line body, an aluminum line body with a preset flow control valve. In this case we have a manual, and what I did was we turned it clockwise all the way and then came back about 20 or 30 degrees or so, and then I snugged the set screw almost to the point where it just makes a little bit of friction on it, so it's not going to easily vibrate around or get too far off a setting. This is a setting that we don't really know what it's supposed to be set at. I think the specification calls for 6 gallons per minute, and the pump volume on this is probably 5 gallons a minute or less. Some of our pressure settings, we can watch the gauges up here on the panel. We can read the pressure gauges up on the panel. I always like to have a backup gauge, let's say a higher quality backup gauge. So we got our pressure checkpoints here and here that we can use, and also out here this will be needed to set the unloading pressure. So moving forward, these checkpoints will always be installed on this project. So as soon as I pull this, push, pull, push off, pull, start, it's going to start up because our pressure is below the set point. Okay, so in its normal operating mode, you're going to have the green light on, which means that the system is on and it could automatically start. These are your 2 warning lights. And as the pressure drops on your lock or clamping pressure, it's going to sense that with the pressure switch, and it's going to automatically start and bring it back up. So it works just like an air compressor. When the pressure in the receiver tank gets low, a pressure switch detects that and starts your air compressor up, and then when it hits its high point, it shuts it off. Works just like that. There's a procedure on the labels telling the operator or reminding the operator how to do its functions. So there's a selector switch right here that is defaults to the run mode, and if you're going to adjust the bowl or release and clear something in the crusher bowl, the procedure is to come over here and the operator turns it to adjust. So if you let go, it springs back to the run position, so that forces the user to have to hold it. And then if that's the case, starts up, they can do whatever they need to do to clear the problem.
So you're gonna go to the run.
The run adjust.
Just point so I can actually see.
Okay, so this selector switch, when moved over to adjust, will automatically start the power unit, and you have to maintain and hold it while you make your adjustment or clear the bowl of any objects that the operations needs done. Quick note on some of the labeling. I just want to run through the labeling. So these are pretty standard. It gives a lot of information to the operator on how and what to do. This label right here, I just have held on by magnets because we're still not positive exactly where they'll want it. Our reservoir in this case is filled up to this point, but by the time you fill 8 accumulators and cylinders, the normal operations is going to take it down a bit. This label right here is placed over the lights and the buttons, describing what each means. We got our 3 gauges right here with the 3 pressure descriptions, and over here we've got our project number, the work order of this particular one, and then what we call the RFQ, or the shop work order. And then on the electrical, we also have, again, I've got the project number and the work order, and some identification and some warning label. I think that's it. Don't forget to smash that like button.
Okay.
I don't know if I have any subscribers.